Now we are going to discuss about the lecture topic, algorithm types and modes. So in the algorithm types and modes, basically there are several types of algorithms. In that particularly in cryptography, the network security, we are going to discuss about the conversion of block ciphers and stream ciphers. So algorithm types, that is what there are two types basically in the symmetric algorithm types. One is the block cipher and stream ciphers. Block ciphers, it operates on blocks of plain text and ciphertext usually of 64 bits, but sometimes it is longer. So we all know about the blocks. So the entire plain text is to be converted in a form of blocks. And in the stream cipher, it operates in the form of streams of plain text that carries the one bit or byte. Sometimes even if it is possible, we can take up to 32 bits at a time. So the algorithms, that is what the block cipher, it is what the same plain text, the blocks which will always encrypt to the same ciphertext blocks using the same key value. There is only one key in the block types. And with the stream cipher, the same plain text bit or byte will encrypt to a different bit or byte every time it is encrypted. So this is the diagram which is used for making the block cipher, that is the conversion of plain text into ciphertext. So each plain text is to be splitted in a form of separate blocks according to the values. There is what values in the sense, there is what in a form of key values. So based on the key value, the initialization vector is to be defined. So the plain text, initially the plain text is to be converted as block ciphers with the initialization vector. And after, once if the plain text is to be converted as a block cipher, then finally the ciphertext is to be taken as in the form of up to 64-bit. So here in the diagram, the three blocks are the continuous, the configurations of the blocks is to be first, second, third. That is what the continuous form of blocks in a single conversion. That is in a separated plain text. So here a plain text which consists of three forms of blocks. And a block cipher comes under in the symmetric cryptographic technique, which we can use to encrypt a fixed size data block using a shared secret key. See, in a block cipher, there is only one key, that is what called as a private key. So during the encryption, we can use plain text and ciphertext. That is what the resultant encrypted text. It uses the same key to encrypt both the plain text and as well as the ciphertext. That key is mentioned here as a private key. So the block cipher, it processes the data blocks of fixed size. That is what the size already mentioned. That is the form of up to 64-bit. Typically, a message's size exceeds a block. If it is possible, means exceeds means. As a result, that's what the lengthy message is to be broken up into a number of sequential message blocks. That's we have discussed already in the diagram. And the cipher operates on these blocks at a time. With the help of the shared secret key, a block cipher encrypts and decrypts its input one block rather than one bit at a time. Since the block size is fixed, padding is not necessary, and it's a symmetric algorithm. So during the encryption, it converts text input into ciphertext using the shared key. That's what the private keys. The private key shared among with the blocks with the continuous formation. It uses the same key during the decryption to change the ciphertext back to the original plain text. The length of the output and the input are identical. So basically the block cipher, it's the popular variations of the block cipher algorithm includes the data encryption standard. That is what the DES algorithm, triple DES, and advanced encryption standards AES. The stream cipher uses a shared key and operates its input one bit at a time, which is the block cipher's counterparts. Alternative to the block cipher algorithm, it includes the public key cryptography and asymmetric cryptography. This algorithm uses the public key to encrypt plain text and a private key to decrypt the ciphertext. Next is the topic with a continuation of block ciphers. Next, we are going to discuss about the stream ciphers. Yes, a stream cipher uses the time varying changes on plain text. Here, the data to encrypt a continuous string of binary numbers. So this method of encryption works bit by bit, utilizing key streams to generate ciphertext for arbitrary length of plain text messages. The cipher combines a key that is in the bit range of 128 bar 256 bits and a nonce digit, that is what called as the 64 to 128 bits, in order to generate the key stream, a pseudo random number. That's what using the XOR gates, that's what it is named as XORed with the plain text to generate the ciphertext. So this is the diagram. It represents about the stream ciphers. So initially a key is to be, while taken the plain text, initially key stream, with the help of the key stream, that is what the key value is to be generated by the use of key stream generator. If the text is to be taken for encryption, after the encryption, the text is to be converted in the form of ciphertext with the key stream generator. And once the ciphertext is converted, then we can convert the decryption text. So here the key stream plays the major role that to convert in both the way encryption and decryption. So the key stream must be different for each encryption iteration, even though the key and nonce can be reused and it also maintains the security. In order to build the key stream, the stream encryption ciphers which generates a unique nonce. Nonce in the sense here a number which is used only once to utilize the feedback in the shift register. So in other words, a stream cipher is a type of encryption that uses plain text number and a stream of pseudo-random cipher digits. Each binary digit receives one bit at a time of the pseudo-random encryption digit stream. This encryption technique uses an infinite number of pseudo-random cipher digits for each key. The primary reason XOR is so useful in cryptography because it is perfectly balanced for given plain text. That is what the input 0 or 1, whether the 0 or 1. The ciphertext results is equally likely to be either 0 or 1 for truly random key bit. The table below shows all the 4 possible pairs of plain text and key bits. It clears that if nothing is known about the key or plain text, nothing can be determined from the ciphertext alone. So this is what are used with the key stream key generator. That is what the streams conversion, the XOR cipher trace table is to be used. For plain text, initially the value is 0, the key also 0, and the XOR gate, like the XOR 0, 0, the possibility is 0, 0, 1, the possibility is 1, 1, 0, the possibility is 1, and 1, 1, the possibility is 0. Thank you.